238,000 miles from Earth, the most brutal environment any human has ever tried to survive is hiding in plain sight. No atmosphere, no magnetic field, no mercy, and every single protection that makes life possible on Earth is completely absent up there. Picture standing on its surface without a suit for 60 seconds. The moisture on your tongue begins to vaporize. Your lungs expand as the pressure drops to nothing. The sun burns exposed skin within seconds, and the silence is total because there is no air to carry a single sound. This is not a story about the journey to the moon. This is a story about what waits on the surface. And the first thing that will kill you isn't what you'd expect. The most dangerous thing about the moon isn't what's there, it's what's missing. On Earth, the atmosphere is a 60-mile thick shield doing dozens of jobs at once, trapping heat, carrying sound, blocking radiation, burning up incoming rocks, and providing the air every living thing depends on. The moon has none of that. Its so-called exosphere is so thin that 1 cubic centimeter of Earth's atmosphere contains 100 trillion times more molecules than the same space near the lunar surface, and that number is not an exaggeration. Without that shield, every other danger multiplies because there is nothing to slow down incoming debris, nothing to buffer temperature swings, and nothing to scatter or absorb radiation. Every single threat arrives at full force, completely unfiltered and unstoppable. Strip away the atmosphere, and the first thing that rushes in to replace it is heat, then cold, then both at once. Most people know the moon is cold at night, but what they don't know is just how extreme both ends actually are and how fast the swing between them happens. Near the equator, surface temperatures during the lunar day climb past 250 degrees Fahrenheit, which is hot enough to cook electronics and degrade the materials in a spacesuit over time. When the sun sets, that same ground drops to 280 degrees below zero within hours, cold enough to freeze carbon dioxide solid, shatter certain metals, and completely drain any battery not specifically designed for it. That swing of nearly 460 degrees from peak to trough happens every single lunar cycle, and here is what makes it even worse. A lunar day is not 24 hours. A complete cycle from sunrise to sunrise takes approximately 27 Earth days, which means astronauts and their equipment must survive 2 full weeks of relentless scorching heat, followed immediately by 2 full weeks of total darkness and bone-crushing cold. The poles are even worse, because in the permanently shadowed craters near the moon's south pole, temperatures have been measured below 410 degrees below zero Fahrenheit, colder than the surface of Pluto. Anything caught in those shadows without adequate thermal protection doesn't malfunction. It simply stops working and stays stopped. But with extreme temperatures, you can at least feel them coming. The next danger won't give you any warning at all. If extreme temperatures are the danger everyone can picture, radiation is the one that does its damage quietly, invisibly, and without any warning at all. Earth is protected by 2 overlapping shields. The atmosphere absorbs and scatters a massive portion of incoming radiation, and the magnetosphere deflects charged particles from the sun before they even reach the atmosphere. The moon has neither, which means the lunar surface sits fully exposed to 3 distinct sources of radiation that would be lethal to an unprotected human over an extended stay. The first is the solar wind, a constant stream of charged particles flowing outward from the sun at hundreds of miles per second. The second is solar flare radiation, which arrives in sudden, violent bursts of high-energy particles with almost no warning and can last anywhere from minutes to hours. The third is galactic cosmic rays, particles accelerated to near light speed by distant supernovas and black holes, carrying enough energy to penetrate solid metal and destroy DNA at the molecular level. NASA estimates that radiation levels in low Earth orbit are already 50 to 100 times higher than what humans experience on the ground. And on the lunar surface, that exposure continues every single day, with no natural shielding to reduce it. Over weeks and months, the cumulative effect increases the risk of cancer, cardiovascular disease, and neurological decline. and a major solar flare striking an unprepared astronaut could deliver a lethal dose within minutes. Future missions planning to build permanent bases will need to bury habitats under meters of lunar soil just to bring radiation levels down to something survivable. And even then, one unexpected solar flare changes the math completely. Now, here is the thing about all these dangers: temperature, radiation, vacuum. They are all things engineers can at least model and plan around. The next threat is 4 billion years old, smaller than a grain of sand, and it is quietly defeating every solution thrown at it. Of all the threats on the moon, this one sounds the least serious, and that is exactly why it might be the most dangerous of all. Lunar dust, technically called regolith, has been accumulating on the moon's surface for over 4 billion years. As every meteorite impact, large and small, has slowly pulverized the rock into a fine powdery layer covering the entire surface, without wind or water to smooth the particles down. Each grain remains razor-sharp at the microscopic level, jagged and irregular like tiny fragments of broken glass. During the Apollo missions, this dust caused immediate mechanical problems. It abraded the boots of spacesuits after only a few hours of walking, clogged the vacuum seals of sample containers, worked its way into equipment joints and mechanisms, causing overheating and failure, and wore down materials at a rate that engineers had not fully anticipated before the missions even began. But the mechanical destruction is secondary to the biological one. When Apollo astronauts returned to their landers after surface excursions, the dust came with them because it clings to everything due to the electrostatic charge built up from billions of years of solar radiation exposure. Once inside the lander, it became airborne and breathable, and multiple astronauts reported sneezing, congestion, and sore throats within hours. Apollo 17 astronaut Harrison Schmitt described symptoms precisely resembling severe hay fever that lasted for the rest of the mission, and those were exposures measured in days. Studies using lunar dust stimulants show that the particles are small enough to reach deep lung tissue, behaving similarly to asbestos or volcanic ash, and the chemical reactivity of the particles, preserved and intensified by billions of years in a radiation-soaked vacuum, may make them more toxic than any natural dust found on Earth. Long-term inhalation risk includes airway inflammation, cellular injury, and increased cancer probability. Solving the dust problem is listed as one of NASA's highest engineering priorities for sustained lunar habitation, and no fully reliable solution exists yet. And while engineers are still trying to figure that out, the moon itself keeps hitting back. The moon is not just sitting there waiting for people to arrive because it is constantly being hit from above, occasionally shaking from below, and quietly taking apart the human body from the inside. Without an atmosphere, space rocks of every size reach the lunar surface intact, and micrometeorites, particles smaller than a grain of sand, travel at speeds up to 45,000 miles per hour. Even at that velocity, even a particle invisible to the naked eye carries enough kinetic energy to punch through a spacesuit, crack a helmet visor, or puncture a solar panel. And the moon is struck by these particles constantly in a process researchers call impact gardening that slowly churns the entire surface layer. Larger impacts are rarer, but very much documented. The European Space Agency's Neliota project monitored the moon for over 6 years and recorded hundreds of visible asteroid collisions. And any one of those strikes occurring near a lunar habitat or landing site would be catastrophic. The ground itself is a separate problem entirely. For decades, scientists assumed the moon was geologically dead, and that assumption was wrong. The moon experiences moonquakes caused by tidal forces from Earth and by the moon cooling and contracting, creating thrust faults that can suddenly slip. A 2024 study analyzing Apollo-era seismic data found that the South Polar region, the exact target of future Artemis landings and base construction, sits near active fault zones where a strong moonquake could destabilize structures, trigger landslides, and compromise any surface habitat not engineered specifically to withstand it. And that is before accounting for what 1/6 gravity does to the human body over months. As bones weaken from reduced load, muscles shrink from lack of resistance, and fluids shift toward the upper body, increasing pressure behind the eyes and blurring vision in ways that have not been fully reversed in returning astronauts. The Moon does not need to strike anyone down because, given enough time, it simply lets the environment do the work. At 238,000 miles, the Moon looks like the closest safe destination humanity could ever reach, and from the surface of Earth, it appears silent, stable, and unchanging. That appearance has never once been accurate. Temperatures swing nearly 460 degrees with a single cycle. Radiation from the sun and deep space arrives unfiltered every second of every day. The dust is sharp enough to destroy equipment and toxic enough to harm lungs. Micrometeorites strike constantly, the ground shifts during moonquakes, and even the reduced gravity is slowly breaking down the human body from within. The Apollo astronauts understood exactly what they were facing and went anyway. They survived not because the Moon was forgiving, but because their missions were short, their preparation was extraordinary, and because they were fortunate. The next generation plans to stay far longer, and the science is worth pursuing. The resources are real, and the strategic and exploratory value is undeniable. But the Moon is not a destination, it is a test, and it has never once failed to punish those who came unprepared.